So now that we know about the proton, if we're watching these in the correct order, you should have just watched the proton one, and now we're ready for the next lesson to describe some of the other properties of some of the other subatomic particles. In this lesson we will consider the neutron, what effect the neutron has on the properties of an atom. We just learned how protons affect what kind of an atom the atom is, and neutrons, first thing we should know, does not. The number of neutrons does not affect what kind of an element it is. If you have 6 protons, you're carbon, and it does not then matter how many neutrons you have. You're always going to be carbon. They do, however, affect the mass. Neutrons will affect how heavy an atom is. Not all atoms of the same element weigh the same, and so we're going to look at that. So let's review. First of all, if we look at the mass, we'll see that the electrons have essentially no mass, whereas the protons and neutrons weigh about the same, about 1 AMU. And so we're going to see that if we want to know the mass of an atom, if we want to count up the protons, neutrons, and electrons of this atom and see what they weigh, well, we don't really care about the electrons because they're so light. So we end up just counting the protons and the neutrons to see how heavy it is. So how heavy an atom is depends only on the number of protons and neutrons the atom has. As we just mentioned, the electrons being so light can be ignored. So, to find the mass number, and this is the big point of this lesson, mass number, just like we learned atomic number, the number of protons was the atomic number. The mass number is not the number of neutrons like you might guess, because the mass number is going to represent the total mass of the atom. So let's look at how we're going to do that. Well, clearly protons have mass, so we have to keep them, but we also have to add in the neutrons. And so that is how we calculate the mass number. It's the protons plus the neutrons. So, symbolically, we can give these symbols. A mass number is referred to as a capital A. Don't ask why for now. And we'll just know mass number. If you ever see, just like Z meant atomic number, protons, A means mass number. It means the protons and neutrons added together. So A equals P plus N. So to show you what that would look like, if we were to make a nucleus, it might look like this. And the blues would be protons and the reds would be neutrons. And so we know that this whole thing looks like that. And if we pulled out the protons, just the blue ones, they look like that. And if we pulled out just the red ones, the neutrons, they would look like that. But if we put them together, they would look like this. And if we just count them up, we can see, well, the mass number, A, is 7. There's 7 circles there. And that is equal to the 3 protons plus the 4 neutrons. And that's all that it matters. So you might ask, well, what about the electrons? Well, we don't care. There could be 7 or 8 or 10 or 1,000 electrons here. We don't really care because that will not, I guess 1,000 would, but you're never going to have 1,000. Those are not going to significantly impact the mass of the nucleus. So, the mass number, this is the same as the last slide, but just kind of a summary, important. A is equal to the protons, P plus the neutrons, which are 4 in this example. We could do lots of other examples. But I want to ask the question, what element is this? And what is its mass number? Well, the mass number should be easy. You might need to refer to your periodic table to answer the question, what element is this? So now, the last thing to know about neutrons is it is possible for 2 atoms of the same element to have different masses. So let's take an example. Here's atom number 1 has 15 protons and 18 neutrons. And some example, atom number 2 has 15 protons and 16 neutrons. Well, if we look on the periodic table, we can determine which atom this is. So we get out our periodic table. We know there are 15 protons, so we look for element number 15, and there it is. It's phosphorus. Element number 15 with atomic number Z is 15 is called phosphorus, symbol of P. So we know that this atom is phosphorus because it has 15 protons, and so is this one. This one is also phosphorus because they both have 15 protons. But when we look at the mass number, we want to add up the protons and the neutrons, and if we look at atom 1, it is 15 plus 18. It weighs 33. If you do see a little dash number next to an element name, that is giving you the mass number, if you ever see that. It's not a superscript, it's not like a charge, it's just like a hyphen followed by some number. That's a mass number. If we look over here at this other element and add up the 15 and 16, we'll see that's 31. So here we have a phosphorus that weighs 31 and a phosphorus that weighs 33, and these are not they're the same element, but they're not the same isotopes. That's a new word there, isotopes. Isotopes are two or more atoms of the same element with different mass numbers due to their different numbers of neutrons. That's